Good afternoon, pilot teachers and students. Good afternoon, class.
Good afternoon, Mr.
All right, thank you very much. You may sit down. All right. Firstly, to remind you that we'll be going through a new unit, and that is on radioactivity. We have started the last topic, that is on electricity. I think most of the work on electricity has been complete. So in this lesson, we'll be basically looking at radioactivity, and we'll be basically studying the atomic structure. Now, in order for us to understand radioactivity more better, okay, some of the information that you learn or some of the knowledge that you gain from chemistry will help you understand radioactivity. For example, information on your knowledge on ions, okay, how ions are formed, reaction rates, and also looking at the atomic structure. Okay, there are different models of atoms. Okay, there are people who come up with different ideas of an atom. So in this lesson, we'll be basically going through and then looking at the atomic structure, looking at where the protons and neutrons are in the atom, and where the electrons are. And then also you'll be finding a number of neutrons, the number of electrons, and nucleons, especially in an atom. So basically, we'll go through and define radioactivity. Okay, radioactivity simply means the breaking down of the nuclei in giving out radiation. So that is spontaneous disintegration. Spontaneous is simply slow breaking down. Okay, disintegration is breaking down of the nuclei in which radiations will be given off. Right? When you look at the elements, there are lots of elements that you have studied, especially in chemistry. 90 of these elements, okay, they have to occur naturally. But then you'll find that only few are more radioactive, while the others are stable. Right? For example, radium, uranium, those are some of the elements that are radioactive. So basically, you can go through, for the pilot students, you can quickly have the definition of radioactivity done. Right? More of this explanation of radioactivity will be given to you later. All right, the two most important keywords that you can find in a definition is spontaneous and disintegration. Okay, so this meaning that it is slowly breaking down. Okay, that is slowly, and that disintegration is for breaking down. All right, you may have finished the definition. We'll now go on to the next. Okay, that is the atomic structure. Now quickly to go through and then, okay, the structure of an atom is almost, let's say the radius of an atom is almost minus 10 times or 10 to the power of minus 10 meters in diameter. That is not diameter, but the radius, okay? And then you have the nucleus, which has a radius or diameter, which is almost about 10 to the minus 15. When you look at the structure of an atom, you will basically find that okay, the electrons will have to orbit the nucleus. And then inside the nucleus you have the protons and the neutrons. So that is basically the structure of an atom according to J.J. Thomson. He was able to come up with the, okay, what is a model? What is J.J. Thomson's model? Can somebody remember that model? Okay, it is known as the plum pudding model. Okay, you will find that the electrodes are in the rings. Outside is a positive sphere. Okay, that is according to Thomson. But then there are other people who came up with different model. Okay, one of them was Niels Bohr, and then you have Rutherford. Okay, so quickly go through and then copy this one. That is the accepted structure of an atom. Okay, maybe, yeah. Yeah, okay, actually, I was meaning that, okay, the first shell and then you have a, yeah. Okay. The diagram maybe, some of you may be thinking that that is a nucleus. Anyway, this is the, okay, the nucleus will be somewhere in there. And then you have the first shell, and then that is the second. So it is just a shell that is outside here, two of the, okay, nucleus will be somewhere there where the protons and the neutrons are. Okay, quickly copy that. Okay. Okay, I will now give you the next piece of information. Okay, that is a okay, the nucleus nucleus is a radius of 10 to the minus 15 meters, and then atoms are made up of tiny particles which are known as the protons, electrons, and the neutrons.
10 to the power of negative 10 radius or diameter?
Okay, I saw that. But I will change that for this one is the radius, only the radius. Yeah. Not diameter should be up there. So, but if you want to write this one, be 10 to the what is how of this? Okay, 10 to the minus 15. If you add another 10 to the 15, it will be 10 to the 30, you see, minus 30. Okay, 10 to the diameter, but radius is only 10 to the minus 15.
So in this case, it will be 10 to the power of 20 for the diameter.
Yeah. Okay, I'll give you. All right, looking at the structure, we've just seen in the structure of an atom, you find those particles will be in the atom. Then you find that the electrons, protons, and the neutrons. Now the charge on each one of these electrons is about 1.602 times 10 to the minus 19 coulombs, and then you have a proton, which is a positive but having the same magnitude or size of this electron. So it is about 1.602 times 10 to the minus 19 coulombs, but this time it is positive. But if you have to look at this, the net charge on this will be negative, and then the net charge on this would be positive. Now looking at the mass of this, how heavy that atom is, an electron is the most lightest. You'll find that it's about 9.31 times 10 to the minus 31 kilogram. And the heaviest of these are the protons and the neutrons, because they have 1.67 times 10 to the minus 27 kilogram each. So that is why when Rutherford came up with his model of an atom, he assumed that the nucleus is more heavier because it has the protons and the neutrons. And then the position in which they are found, electron is outside the nucleus, and then you have the proton inside the nucleus and neutron also in the nucleus. But it has a charge which is 0. After going through this, I will give you, let's say, 1 or 2 activity questions. Some of the knowledge that you learn in chemistry will be used. You can use that to solve the questions. Now, when you finish this, I will proceed with that. Okay, finish, sir. Right, especially when you are given an element like this, you will find that this is the X represents the element, and then you have the A, which is for the mass number. Okay, it can be the mass number or the atomic mass, or it can be known as the nucleon. Okay, it can be known as the nucleon. The nucleon are the protons and the neutrons. Okay, because they are found inside the nucleus, that is why they are called the nucleon. Now looking at this, okay, that is for the atomic mass. But then you have the neutron also, okay, and shows you the neutron number. So when you combine the neutron number plus the, okay, this number, which is the atomic number, will give you the mass number. Now looking at this, also you'll find that this atomic number is an identifying quantity, or okay, it is an identifying quantity of an element. Without that Z number, you cannot recognize an element, and it is almost unique for each one of the elements. However, you will have changes in the mass number because of isotopes. Okay. So quickly go through and then you copy this. For pilot students, you can also have this information done quickly. I will give you your activity in a moment. Right, especially when you are given something like that, you can use, or you can represent. It is not only A in here and Z over on this side, right? You can find that some can be written like this, or it can be, okay, they all mean the same. It can be on the left, or it can be on the right, or one can be on the left and then another one on the right. Okay, the same. Okay, by now you should have finished it. Finish? Yes. Oh. Right, the mass of an atom compared to the mass of carbon-12, right, which is taken to be 12.00 atomic mass, okay, and you also have the gram formula mass, is the mass in a substance expressed in grams. For example, carbon will be 12.00 grams. So quickly go through and then copy only the atomic mass and the formula mass, or gram formula mass. Okay, I'm sure much of this information has been done, especially when you studied chemistry. this one will be carbon 12. Mass of carbon 12, 6, which is compared to 12.00 atomic mass. And then you have the gram formula mass, which is the mass of a substance expressed in grams. Finish. Are you finished? Yes, okay. This is your activity. Quickly have this one. Copy that, and then I'll give you the questions that follows. So pilot students, you can also copy that information. There are 6 of them, and then the questions will be given later on. Okay, number 1 is helium. Then number 2 you have lithium, which is B. C would be chlorine 37, and then you have chlorine 35, which is D. Uranium 235, which is E, and uranium 238. All right. Especially when you look at these two, they show you D. Okay, those are the isotopes of uranium. Okay, uranium 235 and 238, and then you also have chlorine here. Finish. Okay, I will give you the questions for this table here. Okay, how many protons, neutrons, and nucleons are in the following? Okay, that is question number 1. Okay, based on the table that was given to you earlier. Okay, just stand up to answer your question. Protons, neutrons, you decide which one you would go for. So 1, 2, 3 for the first. 1, 2, 3 for the second. Okay. Number 2, B will be 1, 2, 3. You give 1 for proton, neutrons, and nucleons. 1, 2, 3 for the third. 1, 2, 3 for the fourth. Here. 1, 2, 3. I say for the fifth. And then from Solomon, 1, 2, 3, 6. Okay, the rest, starting from Malcolm, you will do the rest, the other questions. Okay? You just stand up, answer your questions, and then you sit down. Okay? You choose who will give the... All right, for this question, for question number 1, you choose each member of the group can give an answer to each one of those. Okay, the proton, neutron, and nucleons. Okay, you start from this.
Do we find this protons, neutrons, and nucleons? Like, nucleons are protons and neutrons.
Yeah.
So, but if
Okay, for that one, for example, what is the proton in here? Proton, you should know that that is 2. What is a neutron? Neutron would be 2. And then you have a nucleon, which is A, which is 4. Okay, for example. Yeah, nucleon is a mass number. Okay, who can give me the, okay, we'll just start with the first one and then we'll go through. Okay, for first, somebody can give me the proton. What is a proton in there for helium?
Helium is proton number of 2.
Okay, the proton number will be 2. Okay, there is the okay. So proton number will be 2, and then what is a neutron? Okay, it is
it's 2.
okay. Neutron number is 2. Very good. And then you have the okay, the atomic number. Atomic number. Okay, it is the mass. mass number. So in here it will be 4. It is sometimes known as the nucleon. All right, good. For this one,
The proton number is 3.
proton number is 3. And then you have the neutron.
The neutron number is 4.
Okay, neutron number is 4. And what about the mass?
The nuclear number is 7.
Okay, 7. Okay, good. Let's go for chlorine 37.
20.
Okay, what is the proton?
What's the proton? 17.
Okay, 17. And this one will be
20.
okay. That is 20 and
37.
37. What about this?
17. 17.
Okay, we have 17 and
18.
said 18 and
52.
30. Okay, it is 35. All right, we will go on to the next, which is for uranium 235 and 92, uranium 238 and 92. Okay, the proton will be for this.
92 protons.
Okay, 92 protons, and then you have the neutrons,
143. 143.
100 and
43. 43.
43. Okay, that will be
235.
235. And then the last one, Ume.
92.
Okay, you have 92, and this one will be, what is a neutron?
The neutron would be 146.
Okay, 146 is the number of neutrons, and then you have the number of, or the mass number, which is
230.
okay, 238. All right, you mastered chemistry well. All right, that is especially looking at the structure of an atom and then how much or how many proton, neutrons, and electrons you can find in there. But we will not be concerned especially with electrons in a wider scope. We'll just look at the nuclear of it, meaning that what is happening in the nucleus. So looking at this, you've just mastered especially the number of protons, neutrons, and mass number with the atomic mass. Okay, that is the atomic number or the proton number, and it is almost equal to the number of electrons. Okay, proton number and electron number are equal. But then you find that in the atomic mass, it is the proton number and the neutron number that make up the atomic mass. So in this lesson, we've just looked at the chemistry, the atomic structure of especially the atoms. Now for question number 2, let's quickly go through and then look at question number 2 before we, okay, what is the element in that X and 6? All right, if we have an element like this, what is the name of that element? Ruli.
One.
Okay, good. That element 6 is, okay, carbon, because you will not find any other elements which has 6 as a atomic number. It is only carbon. So we can say that X is the identifying quantity of an element. Okay, it identifies an element. right, say the number of neutrons if the nucleon is 14. If the nucleus is 14, what is the number of neutrons? Huh? What you tell us?
8 neutrons.
Okay, good. It is 8 neutrons because 8 plus 6 will give us 14. All right, so quickly to go through and then recap on what we did in the lesson, especially when you are trying to study radioactivity. Radioactivity is simply a slow breaking down of the nuclei to give out radiations. But first of all, you must master your chemistry in order to understand radioactivity. And some of the topics that you studied include reaction rates, ions, or atomic structure. Those are some areas in which you have to know about chemistry in order for us to study radioactivity. So with that, pilot students, probably the model teachers will tell you more about the different models of an atom. In the next lesson, we'll go through and then study J.J. Thomson's model of an atom, including Niels Bohr and Rutherford's model of an atom. So basically, when you are talking about this atom, atomic structure and all this have been developed in the past. It has come through many processes until at this stage where we are learning. So meaning that in the early times, the Greeks were thinking that atoms were made up of 4 things: earth, fire, water, and air. Okay, but then it was Aristotle who put out that idea, and then because he was a philosopher, many Greeks believe it. Okay, until we have people who came forward to suggest their ideas of an atom, and from this, learning has improved. All right, so that brings us to the end of the lesson. With that, okay, our key phrase for today will be atomic structure. Good afternoon, pilot teachers and students. Good afternoon, class. Thank you very much. You may sit.